What's going on, everyone? Jeranism back with a live video for you today. Going to be talking about a company with my guest tonight, a company that I call FakeX, but he calls SpaceX, which is also aptly named because he's saying like space X. How that works. My guest is Charles Flat Earth Math. Charles, what's going on?
How you doing, Jeran? I really appreciate the invitation. Thank you very much for hosting.
No problem. I love to talk SpaceX. It's my favorite subject. That's not really true, but I appreciate you joining me too as well, because I saw after I posted the challenge video, I think it was, that was poking fun at their landing sequence, which more times than not seems to black out or skip or lose connectivity because of the curvature of the Earth and they don't have direct line of sight. And even the announcers at this point recognize that's what's going to happen. They kind of warn you, hey, we are going to lose the video here coming up. So making fun of that, David Weiss had sent me a little joke video he did where he flipped his pen or something, and then my wife and I did one, and we put out a challenge to see if anybody could do better. So I'm going to be looking at those later this week. And then I saw you made a comment that basically said, Jeran, you're arguing from a place of non-understanding, and you need to ask questions. Why don't you tell me what exactly your comment said, I guess?
Yeah, it was basically the thing is, I've always found you to ask good questions. And when you ask those questions, there are people, and it doesn't have to be, a SpaceX spokesperson, you don't have to ask them, but there's like lots of people who are knowledgeable as to how these things work. And you could either, accept or reject the explanation, but at least you have the explanation. You might be lied to, or you might learn that there's actually some science behind, what's going on. Like, for example, I just learned that the SpaceX has to request bandwidth from the FAA. Not the FAA, FCC, when they're doing these launches and they want to host the they want to host a live telecast. They actually have to get several channels that they request from the FCC, several channels of bandwidth. And it's either a channel for telemetry for mission control, because mission control, I think, is in California and the launches are mostly in Florida, or it's two channels, one for mission control telemetry and then a second one for video feeds. So it's like, it's a little more complicated than just, the video cut out. How come the video cut out? I thought they had billions of dollars. It's like, there's a little more nuance than that. So that's really where, I want to encourage people to ask questions, not just say it looks fake, therefore it is fake.
Well, if you're gonna do something that's gonna be looking for public support, basically is how I'd put it, or something that is captivating audiences, don't you think it's important to also be with the times? It's 2017, and cameras are not expensive. I mean, you can get a top quality camera for $500, yet they only have one camera. Looking at that, then days later they may come out with a few different video cameras, which simply weren't telecast live.
Sure. And the answer to that is really, really simple. And you can see any live event, whether it's the Super Bowl or some I don't know, just some live event where there's like news coverage. Well, if you were tuned into, I don't know, channel 13 and you're watching it live, there can literally be only one thing on the screen. I mean, unless they're doing a split screen. And so if they cut to some camera angle, or sometimes you see it when they're watching a football game and they cut to the angle and then somebody's picking their nose, right. Well, but like there's like 30 other cameras that are all, filming whatever in the stadium, but they cut to the guy who's picking his nose. So if you watch it live in the moment, you're going to see the guy picking his nose. But then if you watch the stuff later, they're like, oh, well, here's what we caught with our other cameras. Well, then there's, all this other, hours and hours of footage. And the key here is that this drone ship, which is, I don't know, 400 miles off in the Atlantic for the Florida launches. There's no Wi-Fi out there, and so it's like, how exactly do we expect us to get, HD streaming video from that location? It's like, yeah, technologically it is possible, But what I would say is you can only have one thing on the screen at the time. So if they cut to different camera angles, they would think, hey, maybe this camera angle would be better. But then, like you said, the next day, well, that's when they download the stuff off the SD cards on the drone, like well, you'll notice the footage that was shot from a high elevation, that was actually shot from a drone, not a helicopter. And then then the drone literally lands on the ship, on the barge, and then they pull out the card, and then they get full HD footage. But we don't see it right then in the moment. You see that the next day. You'll
notice that if you watch the stuff that comes out the days after, there's never the video camera that cuts out at the landing. It's always the one that was playing live. And that's what I mean by opening it up for deception. Can you, I'm going to share my screen just so we can get some video up here. Make sure you tell me you can see it.
Yes,
see now?
Yes, I can see it.
Okay, so we're looking at CRS-8, which was the very first time that the rocket landed on the ocean drone.
Successfully.
Correct.
This is the first successful. There were several ones where it blew up big time. Correct.
Now, if we're looking at this as if it's a rectangle, right?
Yes.
In your mind, where is this rocket look like it's coming from? I mean, does it look like it's coming from where we are, from our perspective? Does it look like it's coming from the other side of the drone, or does it look like it's coming from the right side or the left side? What do you think that looks like?
Yeah, and I'm going to say and my eyes couldn't deceive me because we're shooting this through a telephoto lens, but it looks like it is coming sort of from our left, sort of in an axis that's sort of in line with the axis of the barge, where you got the shipping containers on both ends of the barge. If you call that the north-south axis of the barge, I don't know what it is, fore and aft, right? The fore and aft axis of the barge. It looks like it is coming along a line that is sort of in that plane, plane, of the barge. Does that make sense?
Well, I didn't understand when you said from our left. I mean, if we're looking at
I'm sorry to tell my left from my right.
Okay.
From our right. Yes.
From our right.
Yes.
Okay. So that's the one. This is one of the views here. And then is this the video here? No. Okay. And then I want to show you the other one. And I unfortunately didn't save it on here, so I'm going to have to screen share from YouTube here and show you this one. Hopefully my mouse is struggling. Okay, and where are we at? This one here.
While you're doing that, I want to say hello to everybody in the chat. Hello, people in chat. There's a spirited conversations going on. Lots of nice comments.
Yeah. Okay, so this is the camera from the rocket. Okay, CRS-8,
yes.
8. Now, when it's coming down here, you'll see here shortly. Okay, so we can see now, just like you said, if we want to call this the north-south axis.
Right, axis of the barge, right.
Right, and it's coming down here towards.
But notice that we are to the I don't know. We're sort of offset. We're sort of on one side of the circle versus the other side of the circle.
Correct.
Yes.
We're on the left side of the circle, right? If you're talking about the landing circle.
Yes.
So we landed to the left of the middle of that circle, to the lower left.
Right.
Okay. So
now,
go ahead. I'm just showing this again.
I was going to say it's hard to see where the smoke is blowing. Which direction the smoke is blowing right after they land, because then that kind of gives you. Mm-hmm. The thing is, I don't really know the exact orientation of the barge. Like when you have the faraway shot, I don't know enough about like the layout of the barge. Like there's one side of the barge has like 2 layers of shipping containers, and the other side of the barge has like 1 layer of shipping containers. But anyway, I will say this: I've worked in the fireworks, not business, but I mean I've set up some really huge shows, some shows that have won awards at firework competitions. Mm-hmm. There's this huge week-long fireworks convention that draws folks from all over the world, and then I worked for 6 days on the show that won first prize at that convention. So I know a little bit about how things look like from a distance. And the thing that amazes me when I'm setting up a fireworks show is that there's huge distances between like the different layers of racks, like the 3-inch racks, the 4-inch racks, and the 6 inches, and then the 10s, and then the 12s. And there has to be, safe distance from the audience. But when you're actually in the audience, you can't tell all those layers. They all look like they're in one layer. And so the I don't know if it's called the visual field gets compressed. Like when you look through it at something through a telephoto lens, everything gets compressed. You really cannot see. In other words, you don't have any depth perception is what I'm trying to say with 100 words. You don't have any depth perception. So for me to say, oh, this looks like XYZ, I'm going to say that with an asterisk. I'm going to say I have no depth perception on this image right here. Maybe it's coming overhead. Maybe it's coming towards us. Maybe it's coming sideways to us. I literally have no depth perception. Do you see what I'm saying?
Yeah, because what I think is obvious in this one, this is why I'm bringing this one up, is I think there is no way you could even rationalize that it is any way legit. Because, okay, so remember when we were watching from the camera on the spacecraft, either way here, no matter how you're looking at depth perception, the camera here looks to be, if you were to draw a line straight down, would be pointed into the water. It wouldn't be pointed.
No, not necessarily. No, and the thing is, the camera on the rocket is, I think it's a standard, wide angle lens. I mean, whether it's a GoPro or whether it's another similar, heavy duty wide angle lens camera. And then please notice that the edges of the rocket kind of form a vanishing. They kind of go to the vanishing point, which is like the dead center of the image, which is a clear indication that the camera is literally pointed exactly downwards, Okay. And so
let me show you real quick though, because
the barge is a little bit off center, No.
But here, I think you're even missing the bigger point. Hold on. So here with my mouse, I'm drawing the square that is the landing pad, right?
Right.
Okay. Not right here. So this is going to land on the lower left-hand corner. Okay, here's the barge. It's landing on the lower left. Okay, well, if we're going to put it into quadrants, it's in the lower left quadrant.
Right.
Correct?
Right.
Now, when we go to this one, the lower left quadrant is over here.
Well, but we don't know where the camera is. The camera could be on the other side of the rocket from us.
True.
So our lower and upper, isn't the same as that. I really, like I said, I can't tell what the orientation of the barge is. Like I can't tell what's fore and what's aft. Do you see what I'm
saying? Yes, I can. But even if you put the camera on this other side, okay, if you put the camera here and it's looking down this way, then you would be coming not towards. See how this is going towards? You're saying that it would be inverted, that we'd be looking the other way. There's basically no way. Go ahead.
All I'm saying is that, like for example, the little sign that says, of course I still love you, which is the writing is upside down. Like on the drone shot from further away, I don't know where that writing is, whether it's towards us or whether it's away from us.
I think they
it's I don't, like I said, I don't know the orientation of the barge, but the point that I'm trying to make is that at long distance photography, it is very, very difficult to see depth perception. And then, I mean, have you seen like the silhouette of the dancer spinning, where it's like a ballerina, sort of like on a music box, how it sort of twirls around, and then they have it be a silhouette. So it's just a black silhouette of this ballerina spinning around. And then what you do is you ask people, okay, is the ballerina spinning clockwise or counterclockwise? And like half the people are going to say clockwise, and the other half are going to say counterclockwise, because you can't. There's no depth perception in a silhouette. Does that make any sense?
Yeah, it makes sense, but there is enough depth perception to tell what side of the ship you're coming from. I mean, for instance, here. Okay, so now we can see.
Okay, yeah, now we can start seeing, and I don't know if you can see. Yeah, you can see the writing, which is on the right side of the barge, right where your mouse is. That's the writing. Correct. So as it kind of zooms in, but I don't see any. I literally don't see any contradiction here. So I was kind of surprised that you sort of called out this footage, because as far as I can tell, that the footage from the rocket matches the footage from the drone.
Okay, so we're here. Okay, we're looking down and we see the top of it is where we know that the writing is, right?
Right.
Okay, so writing's up here, meaning we're coming at it from a perspective that could not possibly be this perspective.
I don't see where you're saying that. Because the thing is, like if you freeze the frame when the rocket is just at the top of your screen, like you freeze it right now, if you were to draw a line straight down, you're going to hit, you're going to hit right there, right where your mouse is. And that's the center frame of the image. That's the center of the image. So if you switch over here, like boom, there's the vanishing point, the exact center of the image is exactly where you had your mouse a few seconds ago. It's in the exact same place. So they confirm each other.
Has to cross the platform.
No, not necessarily cross the platform. The thing is, it's also changing angle. It's, I think that's one of the things that might be confusing you, is that the camera on the rocket is at an angle, because the rocket's at an angle. So that may be a little confusing as well.
Wait, you're saying that the rocket, okay, so right here, you're saying that the rocket is at an angle, right? So the camera's on the other side looking down this way at an angle.
Okay, I'm sorry. Can you take 30 seconds and just fill time? I need to speak to my wife for a moment.
Sure.
Okay, sorry about that.
I'm going to find there's another view too that I wanted to show. So I'll find that. Hello to everyone in the chat. Thank you for joining us. I think Charles is completely missing the point here, but there is another view that is a side view I want to try and find, if I can. Don't remember if it's this one.
Okay, I'm back. I'm gonna have to take a 2-minute break in a few moments. So
anyway.
there is a huge location. I'm sorry, a huge what do I say? Line of inquiry if you're interested in whether they faked this stuff or not, and that is maritime shipping and barges and tugboats. And ports, and if you look in that direction, you'll find that it would be really, really, really hard to fake this stuff, because essentially there is a barge, which is an actual ship that is actually towed out to sea by other real ships that have registry numbers that can be tracked using these maritime tracking websites. And then where it takes off from, where the barge takes off from, the drone ship, is right across the harbor from a Carnival cruise line, or these passenger cruise ships. So thousands and thousands of people can see this empty barge being towed out to sea, and then the thousands more people can see this barge with a 120-foot tall rocket sitting on it being towed back into port.
I'm not claiming that the rocket itself doesn't exist. That's not what I'm claiming.
Right. But the thing is, where did it come from? Where, like that, if you have an empty barge towed out of port and then a full barge towed into port, where'd the rocket come from? And then in between those two events, we have this video, which, you say is fake, of a rocket landing on the barge. And then the next thing you know, the barge is towed back into port, and it's got a rocket on it. So, it's like, yeah, okay, the whole thing could be fake, but we're talking about some, huge
you would
expense.
Hopefully understand that the idea behind the flat Earth truth, or the, the realization, is that it is the biggest deception that there is, that there can be no bigger.
Right. But you will acknowledge that when people start pulling on that thread of deception, that one of the big responses from the flat Earth community is to talk about compartmentalization. I mean, they will literally talk about satellite companies where the people building the satellites don't know that satellites don't work. The people building the satellites don't know that they just splash down in the ocean. The rocket goes up and then it comes down and splashes in the ocean, and because of compartmentalization. So that's kind of a dodge. So what we're talking about here is this huge rocket sitting on a barge that everybody associated with the barge, the people who are tending the tugboats, the people who are operating the crane, and like the longshoremen who work the ports. I'm sure they're union guys. Like, they all have to be in on it. They all have to be in on it, because you can't fake a 120-foot tall used rocket that has still got liquid oxygen and kerosene. It has to be, I guess they call it safed. That's a word I just learned in the last 24 hours. The rocket has to be safed. The excess hydrogen, excess nitrogen has to be bled off. Like all the guys that are doing all this work, they all have to be on the conspiracy. Right?
Yeah, No, no, totally not. What if you're working the shore, you don't get to see the rocket land on the drone ship. You don't get to see anything that goes on out in the ocean. In fact, they shut down everybody from going anywhere near
Sure.
that area for, a day ahead of time, or basically like 10 hours, I think.
So
But
the scenario is basically that there's some secret base or something, or some secret hangar floating in the water that they transfer this rocket from this secret, so like the James Bond, the floating palace, whatever, transfer it onto the barge. The barge comes back into port so that everyone can think that the rocket landed on it.
It sounds like a big expenditure, doesn't it? But when you are cleaning up in money because of this, we think of what people would do for $1,000. Think of what people would do for $10,000. Think of what people would do for $1 million. Think of what people would do for 50 million. I mean, once you get up there, how you can say, it's too big of a nice thing. Couldn't have possibly faked this stuff because it would cost more to fake it than it does to actually do it. I mean,
but then see, now we're talking about all this maritime stuff. So it's all happening out of sight because it's 400 miles off the coast.
Mm-hmm.
Well, now we start landing them at Cape Canaveral. And so now it's actually witnessed by thousands of people, thousands of real people who have P90X cameras. And you can actually see the rocket. Like, you could see the details on the rocket. You can actually see the landing legs deploy as it's coming down. And you can hear the sonic booms. And it's really, really hard to fake. It's hard to fake sonic booms. It's hard to fake seeing a rocket land.
Hard to fake sonic boom. You could just fly a jet over the top of people. They wouldn't even be able to see the jet, and a sonic boom would happen. How could you?
But the point I'm trying to make is that at some point, you start running into an Occam's razor, problem where, if you need 10,000 moving parts to fake something versus one moving part to have it be real, at some point it's just like it would have been easier for them to send a rocket into space and land it.
How heavy this thing is?
The stage managing is just too difficult.
Do you know how heavy this thing is?
Not offhand. It's a couple tons.
Yeah, I think it's 20,000 pounds at its landing dry weight.
Yeah,
and
your car, empty, like mostly empty.
Yes.
Yeah.
Your car weighs 4,000 pounds. Okay, so picture going up to the Empire State Building and dropping your car off of it, and then think that you're going to shoot some flames out the bottom of your car, and it's going to stop your car from falling and hitting the ground. And this thing weighs 5 times, 6 times more than your car does.
Yeah,
it's absolutely preposterous.
Well, it is preposterous if I was just shooting flames out the bottom, like a flame projector, like in theater. But we're not shooting flames. We're actually shooting a Merlin engine. A Merlin engine with 20,000 pounds thrust. And if it's got 20,000 pounds thrust and the rocket weighs 20,000 pounds, it's totally believable that 20,000 pounds of thrust will slow down a 20,000 pound rocket. I'm making up those numbers. Right. Don't quote me on those numbers, but that's not just flames. That's an actual Merlin engine, and it is decelerating the rocket. Hey, Jeran, can you give me 5 minutes? I do apologize. I need to disappear for 5 minutes and help my daughter. I will be back in 5 minutes. And thank you everybody in the chat. The very kind comments. You guys are awesome. All right, I'll be back in 5.
Okay. So I'll just maybe people see what I'm seeing. Maybe they do not. Clearly, let's just watch this again. The angle that this is coming in at, you see this is coming straight in at this angle here. Now watch how it adjusts. This is not adjusting at all. This angle is not changing one bit. You're going straight down at it. This angle comes in. Now watch it turn. Also, the way that it steers is usually based off of the RCS thrusters. And you'll notice here, there's nothing happening here with RCS thrusters. This thing somehow turned. It's coming down at this angle. Now it's going to turn all by itself. Magically turn and land perfectly. Again, this is 5 times heavier than your car. And if you think you can drop it off the Empire State Building and stop it before it hits the ground because you shoot out a Merlin engine, then more power to you. It is simply camera tricks and deception. And I'll remind myself to ask Charles when he gets back why he seems to think that because something can be on video, that it means it must be true. I've seen so many magic shows in my life. I've seen David Copperfield get rid of the Statue of Liberty and people were standing literally right there next to him. And yet at these events, you can be nowhere near the landing. I think that the minimum is 3 miles, and that you have to have special passes for. Most people are around 10 miles away. And if you're 10 miles away from something, and yeah, you can film it with your camera, and if people think that's real, well, I could show you video of somebody making a car appear out of nothing, and somebody would be able to take videos of it, and somebody would be able to take photos of it. And then when they show me, if I'm just supposed to say, oh, that must have happened in reality, that car must have appeared out of nothing because there's video of it, there's photo evidence of it, how could I ever question it? And that's what Charles is basically saying, that he must believe in David Copperfield getting rid of the Empire State Building or getting rid of the Statue of Liberty. Because again, if we just look at the angle coming down here, and it's maintaining this angle, and this thing here, now it's turning. Where's the camera turning? This is going across the barge, landing on the other side. This is coming from this side of the barge and landing on the front side. So it's landing closest to the front edge. This is clearly going over the barge, landing on the far edge. So I'll find there's a 360 video of it too, which is hilarious if I can find it. 360. And I don't know where it is. Usually it's easy to find 360 videos, but I don't see it right now. Where is it? Oh, I think I actually have it. No, I don't have it. 1 second. I think that I have it saved, but I can't play it, but I can get the URL from it. And it would be here. And 360 view first stage landing. 360 view first stage landing. 360 view first stage. There it is. Okay, there we go. So now this view here, so clearly we're on the, as we said, north-south axis, and we can see over here is the words, because it's not over here. And we're going to look up here. Now you would think, basically, the thing lands here in the lower right quadrant this time. So you would assume that the ship must be coming from up here somewhere. And you would also assume that there should be a helicopter. He says it was a drone. So if it was a drone, then I guess you wouldn't see that, but I thought it was a helicopter. And so let's look at this light up here. Where is it? This here is the drone. I mean, is the rocket, believe it or not. Coming down from that angle and landing here. So we can clearly see with that one that the camera is here where my mouse is. Hopefully you can see that. This thing's coming from this angle. I mean, clearly what I see is we got three different things. We got one coming this way, one coming from the right, and one coming from this view. Now, it would actually make sense to me if the camera was here and this thing landed here. That would actually be more in line with the truth. You would say, okay, this camera was looking up, you see it coming down, and it lands on the right side of the camera. But what actually happens is this is the camera. The camera's shining this way, and it lands here.
I'm back, by the way. Thank you for your patience.
No problem. So I wanted to ask you, have you ever seen a magic show like a David Copperfield or somebody?
Yes, I actually saw David Copperfield live, and you cannot tell me he didn't cut himself in half with a laser.
Well, hopefully you see the point that if somebody took a camera to one of those events, that they would show you a picture showing you a car appeared out of nowhere. They would show you the Statue of Liberty disappearing. Sure. So when you say these people got to see, it's not like people are standing at the NASA landing facility watching this thing land. You have to be a minimum of 3 miles away, and I think even for that you have to have special clearance. You know that you have to be like 10 miles away to watch that.
Right. Yeah, but my point is that the, like, let's say you said, oh, it was done with, holograms, or it was done with a big projection screen. The thing is, there are people who are north of the landing site, and there are people who are south of the landing site, and people who are west of the landing site. The one where they land on Cape Canaveral.
No, there's nobody. There's nobody north. Don't say that. There's
nobody north. Oh, because north is all north is the rest of the launch complex.
On purpose, it's all marshland for hundreds of miles. You can't. There's nobody north, so you can.
But my point is that there isn't just one viewing location.
Correct.
Right? There are multiple viewing locations, and then for the launches as well. And so my point is that it becomes a prohibitive exercise in faking that they're sending these rockets up into space, delivering commercial payloads. One of the things I spent time on the last 24 hours is looking up some of the commercial people who are hiring SpaceX to launch their satellites. Okay. And it's like all these people have to be fake as well, and it just sort of defies comprehension. Like there was a provider, but his company wants to provide satellite television to all of Brazil. And it's like, well, how exactly do you fake that?
They're not doing the same thing with balloons. Google Loon isn't doing the same thing. You don't think it's possible to put a balloon 200,000 feet, 150,000 feet in the sky and provide internet from that apparatus?
Not internet. We're talking about television. We're talking about satellite television, where the dish has to be aimed at a very, very specific spot in the sky to within, plus or minus a few degrees.
So here's the thing, though, because you're giving them they're so intelligent, they're so smart that they can build these satellites that remain in orbit and do all these fantastic things. But then when somebody says, could you also put up a balloon with some angle deflectors so that somebody from the ground sends a signal up, it bounces off that balloon, and then anybody who's aimed at that location gets those channels? You're making it like that's impossible. That can't be done.
Okay, so Jeran, that is possible, but it wouldn't be possible to simulate it from a satellite, and it's just a question of geometry. It really, really comes down to geometry. If you are looking at something that is really, really far away and you shoot an azimuth to it, and then you move, say a mile left or right, and then you shoot another azimuth to it, well, you can actually run the angles, and you could determine how far that thing is away. I mean, you could do it with like looking at the Statue of Liberty from New Jersey, and you could
give it all the parameters. The stars are on a celestial sphere. Okay.
A virtual celestial sphere. No, I'm talking about satellites. I'm talking about the geosynchronous satellites.
What I'm saying, though, is that the angle of stars doesn't change whether they're all the same or whether they're all far away, meaning it is the same angle. Regardless of how far away the star is, if it's 100 light years or it's 1 light year, you're still aimed in the same exact direction.
Yeah, when you reach a certain distance away, the distance becomes practically infinity. I mean, that's why on your camera, you've got a focusing ring, and then there's a little infinity symbol, because like at some point it may as well be an infinite distance away. Right. But that's not what I'm talking about. What I'm talking about is if you have somebody who's on the west edge of Brazil and somebody who has an east edge of Brazil, they would be triangulating their quote unquote satellite dishes towards wherever this balloon is with the deflector or whatever. But they're not. They're aimed at the same place, the same location in the sky, which is, 22,000 miles away, at a very specific angle, azimuth and elevation. The satellite guys know more about this than I do, but it's like it's a very, very specific spot in the sky based on that geosynchronous satellite.
So we can triangulate the sun to be 3,000 miles, right? Well,
not really. No, I mean,
that's what I'm saying, is that if you're starting with a baseline of a sphere Earth, and you're saying that these people are aiming in these directions to get to this exact satellite location, that if we rework that out on a plane, then it would work out that they're both aiming in the same direction if you're talking about a balloon 200,000 feet high.
No, this would actually support Lord Stephen Christ's cell Earth or concave Earth, because you literally have to have the ground curving up around for all these satellite dishes to be pointed at the same location. That's just a balloon, a couple 100,000 feet up versus 22,000 miles up.
Wait, the balloon is pointed? What do you mean? You mean
the satellite dishes on the ground? For the satellite dishes on the ground to all be pointed at the same spot, which is only a few hundred, like say 100,000 feet. I mean, balloons really can't get that high, but I know 100,000 feet. That's around where balloons. I think that's near the top edge of balloons, right? 100,000 feet.
A little bit higher than that, but yeah, that's how much an amateur can get.
Right. Now we're not talking about the what is that called? The Echo. What was that one? It was a Stratolite. It was a balloon that was actually a satellite.
The Echo.
That's from the 1950s. But so let's say, your Google Loon or, one of these companies is sending up a high altitude balloon to simulate a satellite. All right. So we'll call it 100,000 feet. If you want to call it 200,000 feet, that's fine. But for everybody's satellite dishes who are aiming at the spot in the sky as if we're 22,000 miles away,
but look at these.
Would have to be concave.
Look at these.
Yes.
They're open for different angles to come at it. So if you're talking about this being 200,000 feet high and somebody who's in the east side of Brazil and somebody who's in the west side of Brazil, and they're both shooting in this general direction, well, yes, their signals might, if you extended them past here, go up to a certain theoretical distance. But it doesn't mean that's where the satellite is. But
you have to understand, imagine drawing a dot in the middle of a sheet of paper. And then you have somebody in the lower left corner of the paper shooting an arrow up to the dot, and somebody in the bottom right corner of the paper shooting up to the dot. Mm-hmm. Well, the dot is the balloon that's faking a satellite. Well, but when you get to outer space, you're ending up in two different portions of the sky. That's the upper left and the upper right hand corner of the paper, and that's only if the satellite was supposed to be twice as high as the balloon. We're talking about a satellite which is supposed to be, 100 times higher than a balloon. And I'm just making that number up. I have no idea what the number is. Mm-hmm. So we're talking about vastly different locations in the sky. Whereas if you have, and like the satellite installation guys know more about this. And there's websites you can go to, Satellite Finder, where you just literally type in the name of the satellite, whether it's DirecTV or, Dish Network or whatever. You type in the name of the satellite and it will actually give you an azimuth. And that is the dot. That is exactly where it is in the sky. And you've heard, and that does not correlate to like a balloon height, I
mean, you've heard Bob talk, my co-host on Globebuster, mm-hmm. and he's a former satellite technician. So how is it that somebody like that can understand how it would work on a flat Earth? And you're just simply saying it could not work, is what you're basically saying.
I don't want to make it sound like I'm casting aspersions. I mean, I think Bob's a great guy. I mean, he looks at the evidence and he comes up with a different conclusion. So I don't want to say anything bad about anybody or anything personal about anybody. He looks at the evidence and he comes up with a different conclusion. But I've tried to encourage him to look into the EME bounce, which is bouncing a radio wave, ham radio waves off of the moon. And then timing it, and he kind of deflects the question. So, there are actual ways of figuring out, like that the moon is approximately 240,000 miles away, using radio waves. But I don't know. It's that we kind of get into an area where if someone genuinely believes the Earth is flat, then they're going to sort of not entertain evidence that it's not flat. And so, and I don't mean to say that as an insult. It's just,
Oh, no. Well, because I believe the same thing for anybody who is committed to the globe. They're not going to look at anything in terms of, well, it could be, or should I look at this from an area of I could be being deceived? And that's my biggest problem with believers in the globe, is that they, even without any personal evidence, without being able to go there, without being able to experiment with space, they simply are buying into what I believe is a story. In fact, I think that space is a computer simulation, that it has been done since the 30s, that they entered in all the data into a computer, and that's why they're able to get away with it, because it's a self-correcting code. It's the same code that Dr. James Gates found at the base of the equations for the universe, and he has taken that on a whole new ride. He now goes around the country telling people that we live in a matrix. And he's a mainstream physicist. The reason he thinks that is because he found the equations at the baseline of the universe. He found zeros and ones. Well, the reason there's 0 and 1s at the bottom of it is because it's all fabrication. There is no such thing as outer space. It's all delivered to you in data. That's why these satellite technicians who build these satellites, like you said earlier, that I think that they're being fooled. Well, they build great satellites. They're absolute great engineers and scientists. They put together these satellites, they put them on a rocket, they see on TV that they get sent up into the sky, and then they go to wait at their computers for data to return. And then the data comes back because it's mathematically programmed to, and they feel that that is enough evidence. Why would they ever even doubt it is the question. In order to doubt it, you would have to be brave enough to like not hook up something correctly on a satellite on purpose to see if it still worked when it got up there. And to do that, you're putting your whole job on the line, your whole livelihood on the line.
Well,
I mean, go ahead.
A great example of that was the Hubble. You know, the people who made the mirror for the Hubble, I think the primary contractor, they'd built spy satellites. And I'm just going by memory, so please don't quote me on this. But if memory serves, the main mirror on the Hubble was ground to the wrong specifications because the primary contractor was doing spy satellites, and they just, they typed the wrong number into the lens grinding machine. And so they built this whole, multi-million dollar, if not $1 billion space telescope, launched it, and it was fuzzy because it was was designed to, with the wrong focal length, essentially. That was a huge mistake. I don't know. I'm sure people lost their jobs over it, and it took, probably another $1 billion to fix it. But that was a huge embarrassment, a tremendous embarrassment. And then every time a rocket blows up, SpaceX blew up a bunch of rockets, and then in trying to land rockets on the barge, they've blown up a bunch of rockets. So, mistakes do happen. But here's a key phrase, and I really want you to think about this, a key phrase for you, Jeran, and that is you can't reverse engineer a lie. You cannot reverse engineer a lie. So like somebody goes and they watch all the Star Wars movies, and they get them in HD, they freeze frame them, and they examine all the technology, and then they build themselves a working lightsaber. And it's like, no, because the lightsaber in the movie is a prop. It's a piece of plastic and metal, and there's special effects that cause the beam to come out. And you can't reverse engineer what is ultimately a lie. And so when we have these satellites, somebody says, oh, I'm going to launch, the two initial satellites for XM were Rock and Roll. I think Rock was over the East Coast and Roll was over the West Coast. Geosynchronous satellites. And then now coast to coast, we all of a sudden, within the span of, a week, had digital radio where you could literally drive coast to coast, tuned into the same radio station, whereas a week before you couldn't, and it's like, well, how do you reverse engineer that? Like, it just doesn't make any sense. You'd have to have, a constellation of 1,000 balloons faking what you can do with one geosynchronous satellite.
And if you look at the cost of that, I would tell you that your 1,000 balloons would probably be cheaper. Do you know what this this thing at the end of this bomb is?
That's the thing that caused. I'm assuming that's the thing that causes it to be an airburst and not a ground burst. I don't know. I genuinely don't know. That's my guess.
Because in my opinion, it's the communication device, and this is the so-called GPS guided. So GPS guides itself to its launch, its bomb location. And isn't it funny that it's pointed at the ground? Because it's not.
But the thing is, but that's your guess that's what that is the communication device. I've never seen. If you can find a one where they're looking at it from the ass end, that's probably where I would guess the GPS unit would be. If you could find, I don't know, it's kind of hard to see. It looks like it's sort of flat on the bottom. I mean, you could at least see that little white circle. That white circle could be a GPS antenna, but that's just me guessing. I mean, I have no idea. But those two prongs sticking out the front, and you could see this on like World War II bombs. You got a fuse that sits on the front, so the thing blows up when it hits the ground, kind of thing. Right, so
that's like its detonator device,
right? I mean, so that's my guess. I genuinely don't know what those two prongs are, but I suspect you don't either, and so you're guessing that they're antennas.
Yeah, absolutely. Because sometimes if you're being deceived, then aren't you forced to make assumptions?
Oh, sure. But I'm happily able to admit my assumptions.
And here, I wanted to show you this. I think you were gone when I showed you. This is the 360 view of the rocket coming down. And so when you're looking up here, okay, and here it comes. This is it here. This.
Right.
And okay, so it's coming down. Come on. Okay.
Oh, so you're able to pan around. Okay, because the original it's just a simple GoPro. So the original. Okay, so what they did is they took the GoPro footage, they ran it into a little QuickTime VR or whatever they call it, so that you can actually pan around the video. But I've seen the original video of that, and I think you showed it in your video.
Yeah, it's coming from off in the distance there.
Right, but I mean it's a standard GoPro lens where if you have a GoPro and you have it horizontally aligned, so it's landscape, not portrait. And you have the bottom of the frame be the deck of the barge. Well, the top of the frame is literally going to be above and behind you. I mean, the GoPro has I don't know, like a 120-degree angle of view. Mm-hmm. So if you have this little, GoPro camera, and you just have the bottom of the frame be the deck of the barge. I mean, you don't need to see anything more than just the deck of the barge. Then literally the top of the frame isn't even straight over your head. It is behind you. It's above your head and behind you. So that's why you see the camera coming in and it looks like the camera's like, doing this crazy curve, from that one camera angle.
We're right here. Then I would assume that if this was the camera looking this way and it landed here, then it would make sense. But this is the camera looking this way. Okay. And it lands here. This does not match at all. You're telling me that camera is right here. This is that 360 camera sitting there.
Yeah. Yeah. So right there, right where your mouse was. Yes. Yes, yeah. Absolutely.
And then from here, you're looking at this thing come from this area. It should be coming from way over here.
No, because it looks like the rocket is coming in, like I said, aligned with the fore and aft axis of the barge.
You're saying this way?
The fore and aft axis. Yes. Yes. But the thing that image, that is, like this is almost directly above our heads. Like that white dot, which is the rocket plume, right, a few frames ago, was almost directly above the camera.
Here you go. Well, so okay, it's just, look where the sun is. Look where the sun is when we look straight in. So it's not coming from right above our head. It's a little bit like maybe.
Well, the sun isn't right above our heads. I mean, it is Florida.
What I mean is if you're looking this way, okay, let's just say we're here. What degree do you think the sun is at? 45?
Well, it's hard to say because I don't have no idea what the focal length of the lens is.
It's not 90.
Well, what I'm saying is you literally can't tell. This is a still taken from a GoPro lens.
Right.
It's still taken from a GoPro. So the angle could be almost anything,
Well, not almost anything. I mean, it can't be 90 degrees. It's not above your head.
Okay. But what I'm saying is with that GoPro,
it could be anywhere from 70 to 40. I'm agreeing with you on that. But to say that the rocket is above our head it's right here. It's coming here and landing on this. We'll call this the lower right quadrant, right?
Right.
Okay. But then to look at this view here, this rocket comes from over here. Now remember, this is the camera here.
Right. But I mean, it's looking right up the ass of the rocket. And
this
right
one
here
it
lands.
Now the rocket is up right here, coming this way. Like I said, this is not crossing over anything. This would make sense if it was going over here, but it's coming here.
Yeah, I was thinking, Jeran, this would take a little bit of preparation, but I was thinking about taking. I've got a digital SLR. It's not, it's a couple years old, so it's not like a P90X. I also have, of course, a cell phone camera, and then I have a GoPro. And I was thinking about having all three cameras running, having the GoPro simulate where that GoPro was, having my cell phone camera be on the rocket ship, and then having the digital SLR play the role of the drone. And then I was going to use like a roll of, empty roll of like a paper towel roll, to simulate the rocket. And I was just going to come in at this angle, and then I was just going to, compare the footage. But the thing is, I don't have that much free time. But to be honest, Jeran, I've worked as a darkroom photographer, a working photojournalist. I used the Dectal and the T9, or I'm sorry, was it T-Max? We used T-Max and Trypan. And I know my way around cameras and lenses, and I honestly see no contradiction. I mean, I hear what you're saying, Jeran, but when I'm looking at that footage, and it's not me being like SpaceX fanboy, I genuinely do not see a contradiction in that footage.
I want to show you one other thing, because again, it makes sense unless you look at all these views and you realize that some of them just do not jive. Okay, so this one here, this is the one you're talking about, right?
Well, that's right, where they showed Right. Where you showed it from several different angles, and the one on the bottom is the GoPro. Now you see the red line, the red dotted line. I don't get that red dotted line.
That's
I
what it
get the
looks like to
green and I
me.
get the blue. I don't get the red at all.
This is where this cam is coming from. It looks like it's coming directly down, and I guess maybe I shouldn't have drawn this line, but maybe come from here down.
Okay.
But I'm trying to say, like, we're going over. You know, you pretend like you're on a roller coaster. You're going up this red ramp, and now you're dropping down. That's what this looks like.
Okay.
They're coming down right there. Okay, so you've got
sort of coming sideways to the barge, not fore and aft, but sideways. Is that sort of what you're saying?
Yeah, you're talking about this is fore and aft, right?
Right. Fore and aft. One's got the 2 layers of shipping containers, and one has the 1 layer. One of these days I'll learn which is which. But
so picture this real quick. This rocket here. Now, right now we're kind of right above it. Okay, we're right above it here. We're right above where we're going to land. And then when you try and jive that with this next scene here, you get there. Come on, move. Okay, here. Okay, this is the same camera, and it's looking off into the distance here. Okay, so now we go back here. That is a camera where my mouse is here, looking this way.
Sure, but it's a super wide angle lens, so literally,
as wide angle as it could be, it's not going to catch something above your head.
Oh, yes, it is. It's a what do they call it? A GoPro. So the top of the frame, if you move your mouse up 1 inch, move your mouse. No, right, the top of the frame literally is behind you. It is above and behind you. Like GoPros have crazy wide angle lenses. All right, so that rocket is almost directly overhead. That's the thing that's the thing that's so confusing about that the light blue footage in the lower right, is that rocket is almost directly overhead, and it looks like do you see the angle? Do you see the rocket, how it looks like it's at a 45-degree angle?
Yeah,
but it's not at a 45-degree angle. It looks like it's at 45 because we're almost looking at it straight up.
So what is the excuse here then?
Well, I mean, it looks like it's a 70-degree angle there, right? But on the GoPro lens, it looks like it's at this crazy horizontal angle. But it's not, because that part of the lens is almost looking directly above our heads.
I would give you that. But then to compare that with this, and you say that there's no issues with that. So this angle, is this angled like as if we're looking down a ramp of 70 degrees, but we should be looking down the other angle? Remember, this is look where the camera is. It's shining this way, and this rocket is coming from here. I mean, I understand what you're saying about, okay, it's above our head, but this camera is looking out this way and seeing the rocket come this way, and it shows the angle as being, if you were looking on like we are, the angle is looking like almost 2 o'clock angle, right? And this is completely different. This is coming from 7 o'clock.
All right, so I just have a thought experiment for you. If you were to take a laser pointer and you were to hold it up and then, like, have a spot on the ground, like put a quarter on the ground or something, and then hold the laser pointer, stretch your arm up, hold the laser pointer up high over your head, and then hit it so that the beam is hitting the quarter, you could have that laser pointer off to the side and then have it gently arc down so that it will, the laser pointer will be pointing to the quarter the whole time, but still be arcing in. Does that make sense?
No, so I'll have to try that. So you're saying if
Yeah,
no,
so let me just explain it again. So you have a laser pointer, you have a quarter, just put a quarter on the ground. Okay. You're standing right next to the quarter. I mean, the quarter's at your feet. You're holding a laser pointer up, as high as your arm can stretch, but you're holding the laser pointer at a slight angle, like maybe at a 30-degree angle from vertical, okay? But you're doing it so that the red dot is hitting the quarter. Right. And then you're just bringing your arm down very gracefully so that the red laser dot is hitting the quarter the whole time, but you're very gently curving down, like the drone footage shows, curving down so that the laser pointer hits the quarter. Okay. Well, now pretend it's not a laser pointer, pretend it's an actual rocket, and pretend that there's a camera on the rocket. Well, what's going to be center frame on the camera? Center frame of the camera is going to be the quarter.
Okay, so you're saying that this thing coming down here, if there was a laser pointer on it right now, you're saying it would be shining at this place it's going to land?
Pretty darn close. Pretty darn close. It's a little bit off center from the rocket footage.
Look at the adjustment there. Why is it adjusting such an angle? This would not point, any laser pointer that you did this to would not stay on the quarter. What you're doing to this thing, you're completely turning it. The fact that you can just look at this and say, and explain it away with, I don't know what you're explaining it away with, but this is clearly aimed out here, not here. and then when it turns, I mean, how can you rationalize that with this? Let's watch them. Watch this.
But the center frame is just off. Now the center frame is inside the circle.
Okay, so when is
inside the inner circle?
When is it doing that adjustment? The adjustment we just saw. When is it doing that? Why did this never adjust? So
I don't understand what you mean by the adjustment. And then I've noticed a couple, because Dave, deep inside the rabbit hole, Dave has been asking questions, and he types out my name, so it draws my attention. But he's like, how is it adjusting? How is it? Let me scroll back.
Sorry, I'm not looking at that. If anybody's,
how does the rocket straighten itself up and deal with the wind and rocking ship? I mean, my understanding is that the wind was not it wasn't a gale force wind. I mean, the wind clearly is blowing, because you do have a couple, some white caps.
Dave does some whatever you call it, wind surfing, ocean surfing, and says that they're blowing about 20 miles per hour. And then he also shows, so we know, somebody can walk underneath this, right?
Yeah, it's huge. I've got a
person can walk underneath the Merlin engine. I wouldn't do it now because it's probably a little bit hot. But if you walked underneath this, so that means that tip right there is about 7 feet off this barge. So now watch how far this ass end of the boat comes up here. Dave says that this would tip it right here. That he was actually showing. Oh, this is a bad video to watch. This is my own video. But he was saying that this is about a 15-foot rise that would make somebody sick and would tip this thing over, which I don't doubt.
Yeah, I actually was doing research into what it would take to tip over a used first stage, and it's 23 degrees is what it would take. 23 degrees would because the center of mass of this thing is a little bit below where that black line, the black line and the white line.
Here.
And that was another thing that confused me is it's the cryogenic tank. That's why it's still white, is because it was, protected from soot.
Picture anything, your car, anything coming down at an angle like this. We can see this angle, and tell me what is steering it to this change. Here's your RCS thrusters, and you can watch them, and they don't shoot one time. Okay, watch the RCS thruster. No shots, and this just adjusted. It just changed its angle. How? With the fins?
Well, but if you watch, if you take any still, you're gonna be like, oh, how did it adjust? Okay, I totally get that. But if you watch the whole video, the thing is, it is curving the whole time. It looks like a side of a parabola. I probably used the wrong word. But I mean, it's arcing down. It's not coming straight down at an angle, and then all of a sudden,
if it starts here and we drew this angle up all the way, this is not adjusting this much the whole time. It's having to adjust from a pretty deep degree angle to get to 90, right? It's like at least 85. I mean, 80,
right. Yeah, but the quick answer is the rocket engines are gimbaled, and then the longer answer is that they've been working on this thing for 4 years. Have you seen the footage of the grasshopper and all the stuff they did down in Texas, where they? You're giggling, but I mean, they've been working on this thing for 4 years with lots and lots of failures. But if you study the footage of the stuff they did down in Texas, where I guess they called it a grasshopper, it was a fake. It wasn't exactly a Falcon 9, but they initially just had it hop, like 1 foot off of the thing and then drop back down onto the legs, and then they had it, go 9 feet up and then hover and then come back down, and then they were hovering, 100 feet in the air, and then they had it go up and then deflect off to the side. At least 100 meters off to the side. See that little dude? That looks like Breaking Bad.
I think this is real is hilarious to me. Well, I can't believe anybody would think this is real. Nobody who can look at it. And this thing makes me laugh. What do they have these blowers and stuff for? People say, "Oh, they reversed the footage," and I'm always like, "Well, I'm not going to say that." But
what blowers? The thing that's right in front. That's
all around.
Yeah, that's a standard fire suppression nozzle. Anybody who knows their way around fire equipment will recognize that.
I don't know what it is. I didn't know. Blower, sucker. What is it? It blows water? I mean, it shoots water?
Yes, probably foam, but yes, it could just be straight water. Yes.
Who's taking this film?
This is from a drone.
Oh, okay. Because you don't see the drone from the other angles. I guess if it's a drone, it would be too small. You think this is real? This is
absolutely
legit footage with these legs on fire.
The legs aren't exactly on fire. I mean, they might be.
They're on freaking fire, dude. They are on fire. Look at the legs. They're burning on fire. They are on fire. There's no other way to describe what they're doing there.
They're smoking. They're smoking. It's probably because the thing is, those rocket engines, they do produce a tremendous amount of heat.
Yeah. I'm sure they do, but I don't think that means that this is real. I would have to see evidence that this is not real, because everything that I've seen, all the clues that I can see. Don't say everything that you've seen.
Your entire life. I don't see anything about this that indicates that it is not real.
Your entire life experience should tell you this isn't real.
Oh my goodness.
Have you ever seen anything else take a long, slender stick that can take off and land because there's fire coming out of the bottom of it? This thing doesn't even have RCS
it's not
thrusters.
Fire, it's a rocket engine. See, that's the thing that Deep Inside the Rabbit Hole was saying. He's like, fire. Fire doesn't cause something to stop. Yes, that's correct. Fire does not cause something to stop, but a rocket engine can. Another area of exploration that you might want to do is look up specific impulse. And it's usually abbreviated capital I and then a small SP. And just look it up. It's a concept used in rocketry, specific impulse. And then that's the rating. That's the thrust rating of a rocket. And for some reason, it's measured in seconds. I never could figure that out. But specific impulse is measured in seconds. And if you want to talk about how much thrust a rocket has or what's its performance, you look at its specific impulse.
It's like I think I came out to 10 pounds of TNT per half second is how much you would need to move the Saturn V.
It was what, 7.5 million pounds of thrust or something like that. I forget the numbers, but it was pretty prodigious.
You could put that into newtons, and then you can put it into pounds TNT. It usually comes out kilograms, but then convert that. I think it was like 9 or 10 pounds of TNT per half second just to keep a thrust. I mean, it's impossible.
Right.
I mean, look at you can take
you could say it's impossible if you think about an explosion, but if you think about combustion and thrust and a de Laval nozzle, you could do all this exploration with model rocketry, of course, at a much smaller scale. But you can build your own rockets, you can make your own rocket fuel, and then you can join these amateur rocketry clubs, and you can learn all about how rocket thrust works.
Why has nobody been ever to put anything in orbit? Amateur rocket company.
The amateur people.
It's so easy.
The thing is, it's not so easy. It's fairly straightforward to build a rocket, but to build a rocket with the capability of going 17,000 miles an hour is not the work of an amateur. So I will give you that. There are no amateurs making things going 17,000 miles an hour.
What is the fastest an amateur can make something go?
Oh, I don't know. It's supersonic, but
that's only
most of these things they go straight up. I mean, like all the amateur stuff, it goes straight up and it comes, fairly straight down, with parachutes and stuff. So
right. So nothing can even come close to 1,500 miles per hour.
What you mean?
No amateur rocket can come close to 1,500 miles per hour.
Oh, I don't know, but I would say 1,500 miles an hour is probably possible from an amateur. Mach 2.5, sure. Yeah.
So you believe
what I was saying was 17,000 miles an hour.
Do you believe this GoPro on a rocket launch to space footage? I know many people have used it pro flat Earth, but I'm just wondering if you believe this.
I've never seen anything about this that caused me to doubt it. But I love the fact that when the D-spin mechanism shoots out, that people say it hits the dome. But
you can just watch the altitude there. That should be enough to look at the temperature.
Well, yeah. The thing is, how can you tell what the altitude is? I mean, you could see the numbers, but I mean, like looking at the ground, you can't tell the altitude.
Right. So they can say anything they want here. I mean, this goes from it's at 15, 16, 17, 18, 19, 20. Watch it go. 22, 25, 36. I just skipped. Okay. 37, 38. 40,000 feet. You're like, okay, 150,000 feet. That's just a 90,000 jump. Not a big deal. Now it's
this has clearly been cut together. I mean, this is not a continuous piece of footage. I mean, you're not, we just cut to the inside of the vehicle and then the outside. This is not, and who's the producer of this? This is GoPro. This is not the actual rocket folks themselves.
I was just asking
if you look at the original footage, right? If you look at the original footage, then you'll see the actual numbers.
Is the original footage able to be found? I thought that was GoPro sites. I thought that was the original footage. I don't know what you would search for.
Well, no, obviously the GoPro stuff, they're advertising their cameras and they're trying to do a marketing thing. So they're gonna cut out the parts where it's just, a big long delay of just gaining altitude. So they're gonna cut stuff out.
Let's do this again, because I want to keep talking about this, because I think that there's so many things wrong with SpaceX, but I got to get on my radio show and
Okay.
So I appreciate you being on. Thank you guys for watching. Jump over to TFR if you want. We go live in about 7 minutes. Thanks.
All right, Jeran. Thank you for your hospitality. You take care. Bye-bye.